Okay, so we are going to factor trinomials. So remember, trinomials are polynomials that have three terms. So they might look like x squared plus 6x plus 8. So that would be three terms. And what we want to do is we want to turn it into the things, the two binomials that were multiplied. So here's my little strategy. I like to take the last number and think of things that will multiply to give me the last number, but add to give me the middle number. And I like to do it in a T-chart because it gives me a little bit more organization of what I can do. Since everything is positive, I'm going to keep them both positive. So 1 times 8 is 8, and 2 times 4 is also 8. If I start adding those together, 1 plus 8 is 9, and 2 plus 4 is 6. This is the guy that actually adds to give me 6, but multiplies to give me 8. So then I just take them over here and rewrite it in my binomials, x plus 2 and x plus 4. So the 2 was from here and the 4 was from here. Now if I go back and double distribute, I would do x times x and get x squared, x times 4 and get 4x. And then I can do 2 times x and get 2x, and 2 times 4 and get 8. And you can see that when I multiply those together, I get x squared plus 6x plus 8. Sometimes they're a little bit trickier though. Sometimes we don't have all positive numbers. So let's look at one where we've got a mixture. I'm going to do the same strategy. I'm going to make a T-chart, and I'm going to take the factors of negative 15, and I'm going to want to add those up to give me negative 2. So I'm going to go through and list what are the factors of negative 15. Well, if I multiply to get negative 15, they have to have opposite signs. So I could be 1 and negative 15, or negative 1 and positive 15. I could be 3 and negative 5, or negative 3 and positive 5. Then when I go through and add them together, this would give me negative 14 or positive 14. This would give me negative 2 or positive 2. And since I'm looking for negative 2, I'm going to pick these guys. So my final solution, when I factor, would be x plus 3, because this is a positive 3, and x minus 5. If you wanted to double check your work to make sure that when you do multiply those, you actually do get this trinomial back, we would do x times x and get x squared, x times negative 5 and get negative 5x, and 3 times x and get positive 3x, and 3 times negative 5 and get negative 15. And then when we combine our like terms, we get x squared minus 2x minus 15, so the two match. There's lots of other ways that I've seen to do factoring. I've seen people just guess and check until they get the right answer. I've seen something called the X box, where they'll do a negative 15 here and a negative 2 here, and then a 3 and a negative 5. I don't personally like that because I like to be able to list out all of my factors, especially for things that don't have just one or two factor pairs, but have multiple. It makes it a little easier for me as a visual learner. We do have a special case called the difference of squares. So if we had a problem like x squared minus 49, we notice that there is no x in the middle. So you could actually rewrite this as x squared plus 0x minus 49. So that middle term would be a 0. We can do the same thing we did before with our T-chart. So we can still do factors of negative 49, things that multiply to give me negative 49, but they have to add to give me this middle number of 0. So I can start listing factors of negative 49, 1 and negative 49, negative 1 and 49, 7 and negative 7. When I go to add these together, I would get negative 48, 48, or 0. Since this matches, I would say that this factored is x plus 7 and x minus 7. The shortcut here, though, is that if I take the square root of each term, that'll give me the first and second terms. So the square root of x squared is x. And the square root of negative 49 is positive 7 and negative 7. And that will work on anything that is a difference, so it has to have a subtraction sign of squares. So both numbers have to be squares. Sometimes we'll see problems that look like this. 4x squared minus 25. 4 is a perfect square and 25 is a perfect square. So we can take the square root of both first and second term. So the square root of 4 is 2. The square root of x squared is x. Square root of 25 is both a positive and a negative 5.